Hello and welcome to this lesson about the Pythagorean Theorem in 3 dimensions. The learning target for this video is to use the Pythagorean Theorem to solve problems that are in 3D. So before we do that, first I would like you to try these problems. Find the missing side length to the nearest hundredth. So do not give me an answer that's in a square root, but actually use the square root function on your calculator and then round whatever your answer is to the hundredth. So in the first two, you have to find the hypotenuse, which is the longest side of it. And then in the third one, I give you the hypotenuse, but you need to find one of the side lengths, one of the legs of the triangle. So take a few minutes and try this, and keep in mind that the Pythagorean theorem is a squared plus b squared equals c squared. After you've done that, you can continue the lesson. Good luck. Okay, now let's talk about a 3D problem and what we're getting at with that. When we're talking about a 3D problem, odds are it's going to be a variation of this. We're going to take a prism, and let's see here. We're going to say, hey, how long is it from this, actually let's go from this corner down to this corner. How long is that? So imagine a box, and if you were to go from one corner to the exact opposite corner, how long is that? Well, there's a couple of things we have to do. First, we have to realize what kind of triangles we have here. So one triangle is from here down. And so what we've done is that with this green line right here, is we've split the base of this in half. And so what we've created are a couple of triangles, or right triangles, because at each one of these corners is a little 90-degree sign. And when we make a 3D triangle, it'll also be 90 degrees. And so what I'm going to do is trace over this green stuff, and I'm going to kind of give you a cross section, and we're going to take a look at that. So we have a rectangle. And in order to find the diagonal from the bottom, like front right corner to the back left corner of a box, we have to at least cut the bottom in half like that. And so here we'll have an A, a B, and then this becomes C. Now, what we have to do is take a look at Mr. Yellow Triangle here. All right, now yellow triangle looks something like this, where we'll call this D. This, the base of it is still C, and then we'll call this E. So we're throwing in several different variables, but we're double dipping on C here. And so the way these are going to work is these A and B are going to be the base dimensions of the box. D is going to be the height of the box, and so A and B can be thought of as length and width. D is the height, and then you're going to have to use the length and width to find the diagonal, and then you'll use that diagonal with the height to then find another diagonal, and you're just doing the Pythagorean theorem twice. So hopefully that makes some sense what we're going to kind of do. And now let's actually look at some examples and see something very similar to that and kind of walk through it with numbers. So in this example, a box used for shipping narrow copper tubes measures 6 inches by 6 inches by 20 inches. What is the length of the longest tube that will fit in the box, given that the length of the tube must be a whole number of inches? Okay, so we're going to have to do some rounding. That last part means we're going to have to do some rounding here. But we can see a very similar shape. So what I'm seeing is, and I'll do this in yellow I guess first, one triangle right here. And that's a right triangle. And I'm going to put this here, so that number is 6. So I see a triangle that is 6 by 20. And I need to find out what S is. So I'll go 6 squared plus 20 squared is equal to S squared. And so I have 36 plus 400 is equal to S squared. S squared equals 436. Take the square root of both sides. And actually what I'm going to do, pro move here, I'm going to say S is equal to the square root of 436. There's a reason why I'm doing that. Because I now know what S is, and that's part of this other triangle I need to find out. This other triangle is S, and then the height, which is still right there, 6, and then R. And so, let me redraw this triangle down here. So we have 6, S, and R. Well, we now know that S is equal to the square root of 436. So when I use the Pythagorean theorem, I'll get 6 squared plus, in parentheses, the square root of 436 squared is equal to R squared. Well, squaring a square root undoes it. So I'm looking at 36 plus 436. I've avoided having to deal with decimals until the very end of the problem. And so R squared is equal to 472. Now I'll take the square root of both sides. And when I use my calculator to figure out what R is, I end up getting about 21.72556. Now, they asked, going up to the question, what is the longest length of tube in number of whole number of inches? Well, that just means I have to cut all that off, and it's going to be 21 inches. So R would roughly equal 21 inches. All right, so that was a lot to process. Let's try another problem, but this time where we have to draw it. So Tina ordered a replacement part for her desk. It was shipped in a box that measures 4 by 4 by 14. What is the greatest length in whole inches that the part could have been? So let's draw this out. We'll have a little rectangular prism. This is 4, this is 4, this is 14. And then I'll kind of draw it down in dashed lines so we can kind of see into it. And what they're getting at is from here to here. Well, we've already played this game. We know that what we're going to get is one right triangle from here to there. And we'll get another right triangle from here to there. And so the green triangle and then the yellow triangle. And we'll work with them separately. Now notice that we'll label something here. So we'll call this S and R just to be consistent with what they did. So this is S and this is also S. Now the rest of it, this is 14, this is 4, and that's still 4 because the height here is 4 as well, and then that's 4 as well. All right, so now it's all about using the Pythagorean theorem. So let's do the green triangle first. We'll get 4 squared plus 14 squared is equal to S squared. Because in order to find R, we're going to need to have S squared, or eventually S. All right, so here we'll get 16 plus 196. That equals 212, and that is equal to S squared. Now, two ways we could look at it. We could either let it be S squared, or we could say S is equal to root 212 and let it be, because we know we're going to use it later on. Because with the yellow triangle, we'll go 4 squared plus S squared is equal to R squared. And so we'll have 16 plus, and then here we'll just kind of take S squared, plug it in right there, 212. So add 16 to that, and that's all equal to R squared. So R squared is equal to 228. Take the square root of both sides, and so we're left with R is equal to, let's see, that is 15.0996, repeating, and then it keeps going, give or take. And so R, in terms of whole number inches, R is roughly 15 inches. So again, the trick here is to use the Pythagorean theorem twice, and that first time is to not overly simplify it. You could either let it be S equals the square root of that number, or you could even stop at S squared is equal to a number, because you're going to have to square it again anyway, so you're just kind of, you're doing an easy substitution there. So let me know if you have any questions. Otherwise, good luck with your homework.